Hi students, today we are going to study the fourth part of the chapter polynomials from class 10 CBSE syllabus. In my previous video we have discussed the geometrical meaning and zeros of the polynomial of a linear polynomial as well as quadratic polynomial. In this video we will discuss the geometrical meaning of the zeros of a polynomial of a cubic polynomial, and we know that the general form of a cubic polynomial is ax cube plus bx square plus cx plus d. Let's consider one example, y equal to x cube minus 4x. In this case I am going to take three examples. Okay, first example is y equal to x cube minus 4x. Second example is y equal to x cube minus x square, and the third example is y equal to x cube. In all these three cases, we will find out the zeros of the polynomial. Look at the first case, y equal to x cube minus 4x. It has two terms. First term is x cube and the second term is minus 4x. And x is common for both the terms, so we can factorize it. That means y equal to x into x square minus 4. And we can again factorize it because x square minus 4 is, by using identity, x square minus a square, 4 is 2 square. Am I right? So we can rewrite it as x into x plus 2 into x minus 2. And we need to find the zeros. Zeros means y equal to 0, or the right side will be 0. That means x into x square minus 4 will be 0, or each term will be 0. X equal to 0 or x square minus 4 equal to 0. X square minus 4 equal to 0 means x plus 2 into x minus 2 is 0. So each term will be 0. That means x equal to 0, x equal to minus 2 and x equal to plus 2. Here three zeros are there. Okay, so polynomial is a cubic polynomial. That this cubic polynomial has three zeros. Now look at the second example, y equal to x cube minus x square. That is also a cubic polynomial, and it has two terms. First term is x cube and second term is minus x square. There x square is common for both the terms. So we can rewrite it as x square into x minus 1, because x square into x is x cube minus x square into 1 is x square. So each term, first term is x square, either x square equal to 0 or x minus 1 equal to 0. X square 0 means x equal to 0. Am I right? X minus 1 equal to 0 means x equal to 1. So x equal to 0 and x equal to 1 are the zeros of this polynomial. Now look at the third example, y equal to x cube. That means here nothing is there to factorize. So x equal to 0 is the only zero of the polynomial. That means from these three examples we can understand that any polynomial of degree 3 can have at most 3 zeros. Now we will see the graph of these three examples. See, first example is x cube minus 4x, and we can take any values for x, and after substituting we will get the values of y. And look at the graph. Here I'm not explaining how to find the points, location of the points. I drew the graph also. So here what we are going to see means zeros of the polynomial. We know that zeros means where it locates, where the graph crosses the x-axis. So look at the graph, 3 points we can see, and these three are the zeros of the polynomial. So that means the value of y will be 0, where the value of y comes as 0. Look at the table. Minus 2, 0 is the first point, 0, 0 is the second point, and 2, 0 is the third point. So what are the zeros? Minus 2, 0 and 2. From the graph also we can understand that minus 2 on the left side, 0 in the middle, and 2 on the right side. So now look at the next example, y equal to x cube minus x square. Here also the graph is given. From that graph we can understand that there are 2 zeros, 0 and 1. We have already solved that. And look at the third example. Here also graph is given, only 1 0. The graph crosses the x-axis at 0 only. So it has only 1 0. That means in general, what we can say? In general, any polynomial p of x of degree n, the graph intersects the x-axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. Polynomial of degree 2 has at most 2 zeros. Polynomial of degree 3 has at most 3 zeros. Polynomial of degree 7 has at most 7 zeros, etc. And so on. Now, look at the exercise 2.1. The first question is the graphs of y equal to p of x are given in the figure. For some polynomials p of x, find the number of zeros of p of x in each case. Here the graph is given, so we have to check whether the graph crosses the x-axis or not. Look at the first graph. The graph is parallel to the x-axis. It does not crosses the x-axis, so it has no zeros. Look at the second graph. The graph crosses x-axis at 1 point, so it has only 1 0. Now look at the third graph. The graph intersects the x-axis at 3 different points, so it has 3 zeros. Now fourth figure, the graph intersects the x-axis at 2 different points, so it has 2 zeros. In the fifth figure, the graph intersects the x-axis at 4 different points, so it has 4 zeros. And last one, the graph intersects the x-axis at 1, 2, 3 points, so it has 3 zeros.